All right, this one is the meaning of logarithms. So as I've discussed before in the previous one about exponents, logarithms are, in short, so an easy way of defining a logarithm, a logarithm is an exponent. Now, that is a very bold statement, and I want to be very careful with how we go about this. This is something that will dawn on us as you go through and practice what we're going to be doing with logarithms. You go through and work with them. At some point, you're going to go, oh, it's just an exponent. So with that in mind, this is the very short end of the stick. We need to really explore what a logarithm is before we can go, oh yeah, it's just an exponent. So with that being said, the definition of a logarithm. It states if a to the x equals b, then log base a of b equals x. Woo. Okay. If a to the x equals b, then log base a of b equals x. We say log base a of b is x. All right, so that's how we're going to pronounce, it's how we read this. Log base a of b equals x. So let's explore this just a little bit more. Here, x is the exponent. The exponent equals all of this. So that's kind of an easy way of saying, hey, a logarithm is an exponent, right? This logarithm is just your x value. So what we're going to do is I need you to understand a couple of things. This a right here, that is a subscript. Really subscript because it's below the main line. So that little base, use your base, that is a subscript, right? It's called subscript because it's below. So we're going to write all this. I don't know where we're going to write it. Let's do it here. So here, this is your sub, and it is the base. B is the argument, called an argument. It goes inside the logarithm. Up here, it was just the answer to whatever a to the x was. All right, so b is just your answer. Well, the answer then becomes the argument. And x here, this is still just the exponent. Okay? All right. Now, being able to go back and forth between exponential form, so let's make sure we understand this, it's called exponential form, and this is logarithmic form. Okay? So you need to be able to go from exponential to logarithmic and logarithmic to exponential. And here is the key to this whole thing. Here's the key. All right, so converting between between two forms, between the forms. The first thing is the base stays the same. Here's what I mean by that. Base of the exponential is a. The base of the logarithm is a. All right, so the base stays the same. The second important thing to note here is that we could say the argument and the exponent, or the answer and the exponent. I'm going to say this, the argument or answer switch with the exponent. I underlined switch 4 times. I'll give 10 imaginary bonus points to whoever emails me and tells me why I underlined the word switch 4 times. Yeah, there you go. All right, so let's practice. We're going to have to practice going from exponential to logarithmic and logarithmic to exponential form. All right, so let's take a look. Our first one here. So rewrite into exponential form. Okay, exponential form. Currently it's in logarithmic and we want to switch it into exponential form. All right, so remember the 2 big key ingredients. 1, the base stays the same, and 2, the argument and the exponent switch. So what is our base here? The base is the 3. So we can say 3 is our base, and then the exponent and the argument are going to switch. So my exponent here is a 4, so 3 to the 4th power equals 1. Yeah, that's it. We're done. Yay. So I went from logarithmic to exponential form. All right, let's take a look at another example. We want to rewrite this into logarithmic form. Okay, so I want to rewrite this in logarithmic form. I need to start with a log. So we're going to start by saying log. Now, I'm going to use a lowercase l here. Sometimes you'll catch me using an uppercase L. And when we get into a little bit more in depth with logarithms, what I want you to understand is the capital L and the lowercase l have meaning. So here I'm going to use a lowercase l because my base, all right, my base, what is my base here? My base is 64, so base of 64. A capital L implies a certain base, and we'll learn about that probably a week or 2 from now. All right, so log base 64. Now, remember, the base stays the same. Now, the exponent and the argument switch. So that 8 then becomes the argument. It was the answer, now it's the argument. And that whole thing equals 1/2. Okay, okay, okay. Not bad. We went from exponential form to logarithmic form. We've got to practice this. I want you to practice this a bunch. We've got plenty of problems on our worksheet to do this. All right, here we go. Rewrite this in exponential form. Okay, remember the base stays the same. So the base is exponential form would be 7 fourths raised to what power? Now remember, the argument and the exponent are going to switch. Here, this is my exponent, so 7/4 raised to the y power equals x. Because it's my argument, now becomes my answer. All right, so 7/4 raised to the y power equals x. Very good. All right, another example here. Rewrite in logarithmic form. All right, now, currently it's in exponential form. The base of this exponent is u. So here I'm going to write log base u. And the exponent and the answer are going to switch. The answer becomes the argument, and the exponent now becomes my answer. And that is all she wrote. Okay, now let's take a look at a couple more examples where this gets a little bit more tricky. So far we went from logarithmic to exponential, exponential to logarithmic, logarithmic to exponential, exponential to logarithmic. And let's see what happens on our next page here. It asks us to evaluate the expression. This is an expression. Notice, there's no equal sign. So yes, it's an expression. So how can I evaluate this? Log base 4 of 64, what does it equal? Well, if I want to evaluate, I'm trying to evaluate, I'm going to say, I don't know what it equals. So I'm going to let it equal x. And now I can switch it to exponential form and try and solve that. So log base 4 of 64, I don't know what that is. So let's switch it to exponential form. The base is 4, and the exponent would be x. So 4 to the x power equals argument of 64. So the answer would be 64. Now 4 to what power is going to give us 6? 4 to what power equals 64? Well, I know 4 times 4 is 16, so it can't be 2, right? X can't equal 2. But 4 times 4 times 4, right? 4 to the third power. Let's see, what's 16 times 4? I don't know off the top of my head. I got to use one of these fancy Dan calculators. But Mr. Stevens, I don't have one of those fancy Dan calculators. And you're right, you don't. I paid a ton of money to get this. What you can do, though, is you can go online and go to desmos.com and go 4 times 4 times 4. Hey, so 4 to the third power. 4 times 4 times 4 is 64. So that gives us, right? So we know that 64 is 4 to the third power. So 4 to the x equals 4 to the third. And that then tells me if I have the same base, then I have the same exponent. That tells me that x equals 3. So if x equals 3, then log base 4 of 64, log base 4 of 64 must equal 3. All right, let's try that one more time. This time might be a little bit more difficult, and that's okay. All right. Log base 347, what, equals 7. Oh, man. So, again, I don't know what it equals, so let's let it equal x. And now 343 raised to the x power equals 7. So 343 raised to the x power must equal 7. Oh, good night. That's kind of tough, right? Because 343 times 2 is going to be way bigger than 7. That's not easy. It's not easy at all. But one thing I do know is that 7 times 7 is 49, and 49 times 7 is 343. I know that 7 raised to the third power is 343. So I can switch this around a little bit, and I could say that instead of 343, I could say 7 to the third, right? Just 343 is 7 to the third. That raised to the x power equals 7. Okay. Well, whenever I have a power raised to a power, what do I do with these? I multiply. So now I get 7 raised to 3x equals 7. And if you don't have an exponent, it must equal 1. Okay, so now I have the same base. If the bases are the same, then my exponents must be the same. So then I can say that 3x equals 1. Divide both sides by 3. So x must be 1/3. Cool. All right, so x equals 1/3. So all of this now, log base 343 of 7 must be 1/3. Cool. Okay, I feel good about that. All right, let's try one more example. Last one. How? Darn it. I'm sorry about that, you guys. Sorry about the boo-boo. It wants us to, oh, got a couple of meth heads walking by. Shh, be quiet. Don't spook the meth heads. They didn't steal a bike today, so they don't have any transportation. Silly osalottery meth head. All right. I have 5 raised to the log base 5 of 17. What is happening? Okay, this is an exponential form. So if I want to simplify this expression, I'm going to say that it equals something. I don't know what it equals. I couldn't tell you. But I have it in exponential form, right? And if it's an exponential form, I could switch it to logarithmic form. Remember, the base stays the same. So log base of 5, the exponent and the answer are going to switch. So of x equals, now the exponent here is a log base 5 of 17. This one's a little tricky, right? 5 is the base, log base 5 of 17. This is the exponent, and it equals x. And then when I switch it, all right, the exponent and the x, these guys switch places. So log base 5 of x equals log base 5 of 17. Now, I have log base 5 of x equals log base 5 of 17. Are the bases the same? Yeah, so the arguments must be the same. So this implies that x must equal 17. Crazy, huh?